Across the world, telescopes are the best way for us to see what's out there in space, but did you know that there's actually one being built with a completely different purpose? It's a telescope at the bottom of the sea. The KM3NET is a next-generation deep-sea research facility that's being built between 1.5 and 3 miles deep in the waters of the Mediterranean Ocean. This research infrastructure will house telescopes that aren't designed to look at light like the ones we're more familiar with, but instead will be looking through the water at neutrinos. There will be 2 telescopes, one known as ARCA, which will allow scientists to search for neutrinos that have been produced by distant astrophysical sources such as gamma-ray bursts, colliding stars, and supernova. The other telescope, called ORCA, is focused on learning more about the properties of neutrinos that have been formed in the Earth's atmosphere. First of all, what are neutrinos? While you may have heard of basic particles such as electrons, neutrinos are probably less familiar. They too are one of the fundamental particles that make up the universe, but very little is known about them. They were first theorized in 1931 and were given their name by Enrico Fermi in 1934 when he developed his theories on radioactive decay. It had been a mystery why energy and momentum weren't conserved in some radioactive decays, and he accurately explained an unseen neutral particle that carried energy away from the process and named it the little neutral one, or neutrino. It would be another 25 years until the first confirmed detection of a neutrino took place, and they were found to be partners of electrons. Electrons carry an electric charge, but neutrinos are electrically neutral, which means that they are not affected by electromagnetic forces. As far as we know, they are only affected by weak subatomic forces that has a much shorter range than electromagnetism. So unlike electrons, which can only pass a limited amount through matter, they can pass huge distances through objects. This means that they are incredibly difficult to detect. There are 3 different types or flavors of neutrinos, each of which is related to a type of electron. The simplest is the electron neutrino, which is associated with electrons, and the other 2, the muon and the tau neutrinos, are associated with heavier versions of electrons. So how does the KM3NET work? ARCA and ORCA are not your ordinary telescopes and have been designed to increase the chances of observing neutrinos. As the particles are neutral, they don't interact with matter very often. In fact, about 1 million of them pass through a fingernail every second unnoticed. However, when they do, on that rare occasion, interact with matter, they produce an electrically charged muon particle. These muon particles travel through water faster than light does, which produces an optical light cone similar to a sonic boom that can be detected. And it's this that the telescopes are looking for. By measuring the arrival time of the light, the path of muon traveling through a detector can be reconstructed, and so can the path of the original neutrino. To do so, KM3NET will eventually be made up of 10,000 optical modules that are photomultiplier tubes contained within pressured glass spheres. They will be positioned across 600 detection units that are 700 meters in length and spaced 100 meters apart. This array will, as a result, be able to closely monitor a cubic kilometer of water. The sensors are installed at depths of many miles because this eliminates any interference from other light sources. And the Mediterranean is perfect because of this optical properties of the water and the closeness to shore to allow the huge data transfer to land that's needed. Crucially, only neutrinos can pass through the center of the Earth, so all the sensors are pointed down instead of up to eliminate any other interference. So with all this work and setup, what exactly are researchers trying to find? This will be the second purposefully built neutrino telescope along with the IceCube in Antarctica, and the results from the 2 are expected to gain a further insight into these particles. The difficulty in detecting them because they rarely interact with anything is also what makes them particularly special. They can be very old and provide information that was created billions of years ago. They are the only particles that can provide data on the universe's earliest moments and from within the cores of astrophysical objects. Scientists hope that studying neutrinos can greatly illuminate our understanding of the universe, our origins, and go some way towards explaining processes that remain a mystery to us. So the new underwater telescope is very different to what you normally think of, and even though it will be facing the direction of the Earth's core, it's on the cutting edge of experimental design for looking out into the universe. Thank you all so much for watching. Until next time.